The current AI wave is advancing faster than public explanations are keeping up. Geoffrey Hinton of the University of Toronto has repeatedly warned that real AI risks and limitations are often understated in mainstream discussions. Artificial intelligence has moved from research labs into everyday products at a rapid pace, but much of the public conversation focuses on visible features rather than underlying constraints. This video examines structural and economic factors shaping the current AI wave. Each point looks at how AI systems are actually built, deployed, and governed today, based on observable industry practices. Number 10. Training costs are concentrating power. Modern AI models rely on extremely large computational workloads that require specialized hardware, stable energy supply, and long development cycles. Training a frontier-scale model involves processing vast data sets across thousands of high-end accelerators for weeks or months at a time. Companies such as OpenAI, DeepMind, and Anthropic operate at this scale by securing long-term access to data centers and custom AI chips. Cloud providers like Microsoft, Google, and Amazon supply the infrastructure that enables these training runs. Smaller research groups and startups typically cannot afford independent training and instead rely on shared cloud platforms or licensing agreements. This concentration of resources gives a small number of organizations structural advantages in experimentation speed and model iteration. By 2025, leadership in training the largest models is expected to remain concentrated among firms with direct access to capital, compute, and infrastructure partnerships. Number 9. Data quality matters more than model size. AI performance is shaped not only by model architecture, but also by the quality and relevance of training data. As models grow larger, improvements from additional parameters alone have begun to slow. Companies now invest heavily in curated data sets, synthetic data generation, and human-labeled data pipelines. Meta, OpenAI, and Google have publicly discussed the limits of scaling raw internet data without careful filtering. Specialized teams now focus on data deduplication, bias reduction, and alignment-related annotation. High-quality data improves consistency, reduces errors, and makes models more adaptable to real-world tasks. By 2025, organizations with strong data strategies are likely to see more reliable gains than those focused only on increasing model size. Number 8. Most AI products are narrow, not general. Despite frequent references to general intelligence, most deployed AI systems are designed for specific functions. These systems perform well within defined boundaries, but do not generalize broadly across unrelated tasks. Examples include recommendation engines used by Netflix and Amazon, coding assistants integrated into Microsoft and GitHub products, and image recognition tools used by Adobe. Customer support chatbots, fraud detection systems, and document processing tools are all optimized for narrow objectives. These systems are effective because they operate within constrained environments with clear success metrics. In 2025, most AI tools in active use are expected to remain domain-limited and task-specific. Number 7. Inference costs are becoming the bottleneck. Once a model is trained, it must be run repeatedly to serve users, a process known as inference. At scale, inference can exceed training costs, especially for consumer-facing applications. NVIDIA, AMD, and Intel are designing hardware specifically aimed at efficient model execution rather than training alone. Companies are adopting techniques such as model distillation, quantization, and caching to lower operational costs. Inference efficiency directly affects pricing, availability, and product margins. In 2025, inference optimization is expected to play a major role in determining which AI products remain economically viable. Number 6. Regulation is lagging behind deployment. AI systems are entering public and commercial use faster than regulatory frameworks are being finalized. The European Union's AI Act and evolving U.S. executive guidance represent early attempts at structured oversight. Companies like Microsoft and Google have formed internal policy and compliance teams to interpret emerging rules.
Different regions are adopting different risk-based approaches, leading to uneven enforcement standards. In 2025, regulatory uncertainty is expected to remain a key factor shaping how and where AI systems are rolled out. Number 5. Open models are catching up quickly. Open-source AI models have improved significantly in performance and usability. These models allow organizations to inspect, modify, and deploy systems with greater control. Meta's Llama series and releases from Mistral have demonstrated competitive results on standard benchmarks. Developers increasingly fine-tune open models for internal tools, customer support, and specialized workflows. Enterprises often prefer open models for compliance, customization, and data governance reasons. By 2025, open models are expected to see broader adoption across commercial and institutional environments. Number 4. AI reliability is still inconsistent. AI systems can generate outputs that appear confident but are factually incorrect. Hallucinations occur when models produce unsupported statements based on patterns rather than verified sources. Companies such as OpenAI and Anthropic use reinforcement learning and evaluation frameworks to reduce error rates. Production systems often include secondary verification layers or human review checkpoints. In 2025, improvements in reliability are expected to continue gradually rather than reach a definitive solution. Number 3. Human oversight is still essential. Most real-world AI deployments rely on human oversight to ensure accuracy and accountability. Content moderation systems use human reviewers alongside automated filters. Medical imaging tools support clinicians rather than replace them. Legal and financial AI applications often require mandatory human approval. In 2025, human-in-the-loop processes are expected to remain a standard requirement for responsible AI use. Number 2. Job impact is uneven, not universal. AI tends to automate specific tasks rather than entire professions. Its impact varies widely across industries and job roles. Repetitive cognitive workflows such as data entry, scheduling, and basic analysis are most affected. IBM and Accenture focus on AI-assisted productivity rather than full automation. In 2025, job transformation is expected to outweigh large-scale job displacement. Number 1. Progress is real but slower than headlines suggest. AI capabilities continue to improve through steady research and engineering advances. Benchmarks show measurable gains, but real-world integration exposes technical and organizational constraints. Research labs frequently publish breakthroughs that require years to mature into stable products. Implementation involves testing, regulation, and infrastructure adaptation. In 2025, AI growth is expected to remain strong but constrained by practical limits. Together, these points show an AI wave driven by economics, data, and operational limits rather than hype. The next video will examine what AI can realistically replace in the next 5 years. If you think an important factor was missed, you can share your view in the comments.